Imagine looking up at the night sky and realizing that something from another star system is silently racing past us at incredible speed. In the summer of 2025, astronomers detected exactly that. A mysterious visitor from the depths of interstellar space that has been traveling for millions of years before finally reaching our solar system. This cosmic wanderer, known as 3I Atlas, represents only the third confirmed interstellar object ever discovered. Today we'll explore everything scientists have learned about this extraordinary celestial traveler, and what it reveals about our galaxy. Discovery of 3I Atlas. Here's the moment that changed our understanding of interstellar visitors forever. On July 1, 2025, the Atlas telescope system at Rio Hurtado Observatory in Chile captured images of an unusual moving object racing through space at 61 kilometers per second. The Discovery team, led by Larry Deneau from the University of Hawaii's Institute for Astronomy, immediately recognized that this wasn't an ordinary asteroid or comet from our solar system. The object's hyperbolic trajectory and extreme velocity indicated it was following an escape path from our sun's gravitational influence. Initially catalogued as A11PL3Z, the mysterious visitor was positioned 4.5 astronomical units from the sun, approaching from the direction of Sagittarius. What made this detection particularly remarkable was that pre-discovery images dating back to June 14, 2025, revealed the object had been approaching undetected for weeks. The reason for this delayed discovery was its trajectory through the dense star fields near our galaxy's center, where countless background stars made it nearly impossible to spot against the crowded stellar backdrop. Within hours of confirmation, observatories worldwide began tracking this rare interstellar wanderer, setting the stage for one of astronomy's most significant discoveries. Atlas Survey System. But here's where this discovery became truly historic and earned its place in astronomical records. After extensive trajectory analysis by the Minor Planet Center, the object received its official designation as 3Y Atlas, where 3I signifies it as the third confirmed interstellar object in human history. This places it alongside the famous 1I Oumuamua discovered in 2017, and 2I Borisov found in 2019. However, 3I Atlas quickly distinguished itself from its predecessors in a remarkable way. Karen Meach from the University of Hawaii and her international team confirmed on July 2, 2025, that the object was displaying clear cometary activity. Unlike Oumuamua, which remained enigmatically inactive throughout its visit, 3Y Atlas developed a visible coma and tail almost immediately after discovery. Observations from the Nordic Optical Telescope revealed the comet was clearly active with a distinctive tail measuring at least 25,000 kilometers in length. John Tonry, principal investigator of the Atlas project, noted that this discovery validated their sky survey system's capability to detect rare astronomical phenomena. The rapid identification of cometary activity made 3Y Atlas the second confirmed interstellar comet, providing scientists with an unprecedented opportunity to study active sublimation processes in a visitor from another star system. Object classification and naming. Now prepare to be amazed by the sheer scale of this interstellar giant. Recent observations conducted by Marco Micheli from the European Space Agency using the Vera C. Rubin Observatory have determined that 3Y Atlas measures approximately 11.2 kilometers in diameter, making it significantly larger than both previous interstellar visitors combined. This massive size has profound implications for scientific study, as larger objects retain more of their original composition and provide clearer observational targets for detailed analysis. The comet's substantial nucleus is surrounded by an active coma that exhibits a distinctly reddish coloration, remarkably similar to what was observed in 2I Borisov. Daryl Seligman from Michigan State University, who led the initial characterization studies, noted that this color similarity suggests interstellar comets may share common compositional characteristics regardless of their stellar origin. The impressive scale of 3Y Atlas means it will remain visible to Earth-based telescopes for an extended period, giving researchers months rather than weeks to conduct comprehensive observations. This extended visibility window represents a golden opportunity for the astronomical community to gather unprecedented data about interstellar comet composition, structure, and behavior as it interacts with our sun's radiation and solar wind during its passage through our solar system. Orbital characteristics. Okay, here's something that will really blow your mind about this cosmic time capsule's incredible journey through space. Based on detailed orbital mechanics calculations performed by Davide Farnocchia at NASA's Jet Propulsion Laboratory, scientists believe that 3I/Atlas actually originated from the Milky Way's thick disk region, where ancient stellar populations reside. This means the comet is potentially around 7 billion years old, which is, well, older than our entire solar system by approximately 2.5 billion years. Its epic journey likely began when gravitational perturbations from massive planets or maybe even close stellar encounters ejected it from its birth star system eons ago. For millions of years, this ancient wanderer drifted through the frigid vacuum of interstellar space at temperatures approaching absolute zero, which honestly perfectly preserved its primordial composition like a cosmic freezer. Sam Dean, an amateur astronomer who helped identify additional pre-discovery observations, contributed to tracking the comet's path backwards through time. The comet's trajectory suggests it has been traveling through the galaxy's spiral arms, potentially witnessing the formation and destruction of countless star systems during its incredible voyage. This preservation makes 3I/Atlas an invaluable scientific specimen, carrying within its frozen nucleus the chemical signatures and formation conditions that existed in a distant star system billions of years ago, offering unprecedented insights into galactic evolution and early planetary system formation processes. Physical properties. But here's what makes this discovery even more extraordinary: the unprecedented international scientific collaboration that made it possible. The research effort was spearheaded by Michigan State University's Darrell Seligman, who coordinated with a global network of observatories and research institutions to maximize observation time and data quality. Robert Warwick from the University of Western Ontario, who previously discovered 1I Oumuamua, provided crucial expertise in interstellar object identification and tracking protocols. The collaborative team included researchers from the European Southern Observatory, NASA's Goddard Space Flight Center, and the Harvard-Smithsonian Center for Astrophysics, really demonstrating how modern astronomy relies on rapid international cooperation. Grigory Fedorets from Queen's University Belfast contributed orbital dynamics expertise, while Tony Farnham from the University of Maryland provided cometary activity analysis. This coordinated effort represents one of the most comprehensive rapid response campaigns in astronomical history, with over 50 professional observatories and numerous amateur astronomers contributing observations within the first month of discovery. The team's ability to quickly organize this global response ensured that critical early observations were captured before the comet's activity levels changed, maximizing the scientific return from this rare interstellar visitor and establishing new protocols for future interstellar object studies. Comet activity features. Now let's trace the incredible path this ancient wanderer will take through our solar system over the coming months. 3I/Atlas will reach its closest approach to the Sun, called perihelion, on October 29, 2025, at precisely 11:41 Universal Time. At this crucial moment, it will be positioned 1.36 astronomical units from the Sun, that's about 203 million kilometers away, perfectly situated between the orbits of Earth and Mars. This optimal distance means the comet will experience significant heating without being destroyed by extreme solar radiation. During its approach phase, the comet will have several notable planetary encounters that provide unique observational opportunities. On October 3, 2025, it will pass just 0.19 astronomical units from Mars, only 28 million kilometers away, potentially allowing Mars-based instruments to conduct close-range observations. Following perihelion, the comet will swing past Venus on November 3, 2025 at a distance of 0.65 astronomical units. Most importantly for Earth-based observers, our planet remains completely safe throughout this cosmic dance. The closest 3I/Atlas will approach Earth is 1.8 astronomical units on December 19, 2025. That's about 270 million kilometers away, providing excellent viewing conditions while maintaining a comfortable safety margin. This trajectory offers astronomers multiple observation windows from different vantage points throughout the solar system. Amateur contributions. Here's where the scientific excitement reaches its peak: the detailed analysis of this interstellar visitor's composition and structure. Spectroscopic observations conducted by Alan Fitzsimmons from Queen's University Belfast using the Gemini Observatory have revealed that 3Y Atlas is composed primarily of water ice, silicate minerals and organic compounds similar to comets in our own solar system. However, the presence of exotic isotopic ratios in its gas emissions suggests formation conditions significantly different from our local environment. Bin Yang from the European Southern Observatory detected unusual concentrations of deuterium-rich water vapor, indicating the comet formed in an extremely cold environment around a different type of star. As the comet approaches the Sun, increasing solar radiation is causing accelerated sublimation of volatile ices, revealing deeper layers that have remained frozen for billions of years. Jacqueline Keane from Boston University has identified traces of carbon monoxide and methane in the comet's tail, providing insights into the chemical conditions of its birth star system. The James Webb Space Telescope, under observations led by Stephanie Malam from NASA Goddard, has been scheduled to conduct detailed infrared spectroscopy to identify complex organic molecules that might exist within the comet's nucleus. These compositional studies are providing unprecedented insights into star formation processes and the distribution of life-building molecules throughout our galaxy. Surface composition. But here's what makes this observation campaign truly revolutionary: the unprecedented coordination of space-based and ground-based telescopes working together. Paul Chodas from NASA's Center for Near-Earth Object Studies has coordinated orbital predictions that allow telescopes to track the comet with extreme precision. The Hubble Space Telescope, under the direction of Matthew Knight from the Naval Research Laboratory, captured high-resolution images on July 21, 2025 that revealed intricate details of the comet's coma structure and dust distribution patterns. Ground-based facilities including the Very Large Telescope in Chile and the Keck Observatory in Hawaii have been providing continuous monitoring of the comet's brightness changes and spectral evolution. Quanzi Ye, from the University of Maryland, has been leading photometric studies that track how the comet's activity levels change as it approaches the Sun. The NEOWISE Space Telescope has been measuring infrared emissions to determine the comet's temperature distribution and internal heat sources. This coordinated campaign represents the most comprehensive study of an interstellar object ever conducted, with data collection continuing through September 2025, before the comet passes too close to the Sun for safe observation. The wealth of data being collected will provide material for scientific studies for decades to come, advancing our understanding of interstellar chemistry and planetary system formation processes. Interstellar object density. Now here's something that sounds like science fiction but is being seriously considered by space agencies worldwide. Atsuhiro Yaginuma, an undergraduate researcher working with Daryl Seligman at Michigan State University, is conducting detailed trajectory analysis to determine whether a rapid spacecraft mission to 3Y Atlas might be feasible. The challenge is enormous. Intercepting an object moving at 61 kilometers per second would require unprecedented propulsion technology and launch timing precision. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory has been evaluating existing spacecraft designs that could potentially reach the comet during its closest approach to Earth in December 2025. Such a mission would need to launch within months of the discovery, requiring massive international cooperation and emergency mobilization of space resources. Alan Stern, principal investigator of the New Horizons mission, noted that while technically challenging, the scientific payoff from getting close to an interstellar object would be revolutionary. A successful intercept could provide direct samples of materials from another star system, potentially containing organic compounds or even microscopic signs of extraterrestrial life. Even if a full intercept proves impossible, the research being conducted is advancing rapid response space mission capabilities and establishing protocols for future interstellar object encounters. The mere possibility represents a remarkable leap in humanity's ability to explore beyond our solar system. Origins and age speculation. Finally, here's the most profound implication of this discovery for the future of astronomy and our understanding of the cosmos. The detection of 3I Atlas, following Oumuamua and Borisov, is providing statistical evidence that interstellar objects are far more common than previously estimated. Mark Norris, from the University of Central Lancashire, has calculated that approximately one interstellar object larger than 100 meters passes through our solar system every year, though most remain undetected. Robert Jedicke from the University of Hawaii estimates that the Atlas survey system, with telescopes in Hawaii, Chile, and South Africa, will detect several interstellar objects annually as technology improves. The Vera Rubin Observatory, scheduled to begin full operations in 2025, is expected to revolutionize interstellar object discovery with its ability to scan the entire visible sky every few nights. Michelle Bannister from the University of Canterbury predicts that within a decade, we'll have discovered dozens of these cosmic wanderers, providing a statistical sample large enough to understand galactic dynamics and planetary system evolution. Each new discovery adds pieces to the puzzle of how materials and potentially life itself might be distributed throughout our galaxy. 3. I-Atlas isn't just a single remarkable discovery, it's opening an entirely new field of astronomy that studies the messengers traveling between star systems, carrying secrets from across the galaxy. From its ancient origins in the thick disk of our galaxy to its spectacular journey past our sun, 3I-Atlas has revolutionized our understanding of interstellar visitors and the materials that travel between star systems. This cosmic time capsule, preserved for billions of years in the cold of space, continues to reveal secrets about distant worlds and the formation of our galaxy itself. As we track its departure back to interstellar space, we can only wonder what other mysteries await discovery. Like, share, and subscribe to InnoVision Tech for more cosmic revelations. What if the mysterious object racing through our solar system isn't what it appears to be? Fresh observations of 3I/Atlas are revealing characteristics so unusual that some scientists are questioning whether we're dealing with a natural comet at all. This interstellar visitor's trajectory, timing, and behavior patterns are defying conventional explanations, leading to heated debates in the scientific community. Today, we'll examine the mounting evidence that suggests this cosmic wanderer might be far more extraordinary than anyone initially imagined, and explore the controversial possibility that we could be witnessing something truly unprecedented. Discovery and initial detection. The story of 3I/Atlas begins with a routine sky survey that would soon turn extraordinary. On July 1, 2025, the Atlas telescope system at Rio Hurtado Observatory in Chile captured images of an unusual fast-moving object designated A11PL3Z. Larry Deneau from the University of Hawaii's Institute for Astronomy immediately recognized that this wasn't an ordinary solar system object. Within days, follow-up observations confirmed what astronomers had suspected. This was the third confirmed interstellar visitor in human history, joining the ranks of 1I Oumuamua discovered in 2017 and 2I Borisov found in 2019. The object received multiple designations, 3I-Atlas for its interstellar status, and C2025N1 for its cometary characteristics. What made this discovery particularly intriguing was that despite entering our solar system weeks earlier, 3I-Atlas had remained undetected due to its challenging viewing angle against the dense star fields near Sagittarius. John Tonry, principal investigator of the Atlas project, noted that pre-discovery images dating back to June 14, 2025 revealed the object had been silently approaching our solar system for an extended period. This late detection would prove to be just the first of many unusual characteristics that would set 3I-Atlas apart from any cosmic visitor we'd ever encountered. Extraordinary orbital characteristics. Prepare to have your mind blown by the absolutely extraordinary orbital mechanics of this interstellar wanderer. Davide Farnocchia from NASA's Jet Propulsion Laboratory has calculated that 3I-Atlas follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest value ever recorded for any known interstellar object. This mathematical measurement indicates just how dramatically different this visitor's path is from anything bound to our solar system. Even more remarkable is its incoming velocity of 58 kilometers per second, making it the fastest interstellar visitor ever recorded approaching our cosmic neighborhood. But here's where things get truly suspicious. The trajectory lies almost perfectly within the ecliptic plane, the flat disk where most planets orbit the Sun. Marco Micheli from the European Space Agency has calculated that the probability of this alignment occurring by random chance is merely 0.2%. This isn't just unusual, it's astronomically improbable. Most objects from interstellar space would approach from random angles, yet 3I Atlas chose a path that seems almost deliberately designed for optimal planetary encounters. The precision of this trajectory has prompted some researchers to question whether we're witnessing natural celestial mechanics or something far more intentional. Such mathematical precision in cosmic trajectories typically requires either extraordinary coincidence or deliberate planning. Suspicious planetary encounters. The planetary encounter sequence of 3I Atlas reads like a carefully choreographed cosmic ballet that defies statistical probability. Robert Warwick from the University of Western Ontario, who previously discovered Oumuamua, has analyzed the object's path and found it passes unusually close to Venus, Mars, and Jupiter during its solar system transit. The probability of such close encounters occurring randomly has been calculated at an astounding 0.005%. Essentially impossible by chance alone. But the timing gets even more suspicious. Paul Chodas from NASA's Center for Near-Earth Object Studies has determined that 3I Atlas reaches its closest approach to the Sun precisely when Earth would be positioned on the opposite side, blocking direct observation during the most critical phase of its visit. The statistical probability of this alignment? A mere 7% chance. Karen Meach from the University of Hawaii has noted that rather than resembling the chaotic path of a randomly ejected comet, the trajectory appears optimized for studying the inner solar system planets while minimizing detection risks. This orbital choreography provides optimal vantage points for comprehensive planetary observations, exactly what you'd expect from a reconnaissance mission rather than a chance cosmic encounter. The mathematical precision required for such a trajectory suggests either unprecedented natural coincidence or deliberate design by an intelligence capable of interplanetary navigation. Physical properties and anomalies. The physical characteristics of 3I/Atlas are equally perplexing and honestly challenge our understanding of typical interstellar objects. Daryl Seligman from Michigan State University has determined that the object measures somewhere between 1 to 12 kilometers in diameter, making it significantly larger than both previous interstellar visitors and providing an unprecedented opportunity for detailed study. Spectroscopic analysis suggests this cosmic wanderer is extraordinarily ancient, potentially 7 billion years old, predating our entire solar system by billions of years. This makes it a genuine cosmic fossil, carrying secrets from the early epochs of our galaxy. Quanzi Ye from the University of Maryland has confirmed that 3I/Atlas is the brightest interstellar object ever observed, allowing for detailed spectroscopic analysis that just wasn't possible with previous visitors. Perhaps most intriguingly, the object exhibits a 29-hour rotation period with minimal brightness variation, suggesting either a spherical shape or a uniform surface composition, characteristics that are pretty unusual for natural comets. Matthew Knight from the Naval Research Laboratory has noted that high-resolution observations reveal a remarkably compact and dense appearance, lacking the typical fuzzy, diffuse structure expected from ancient comets. These physical properties suggest either an unusually well-preserved natural object or something with a fundamentally different composition and structure than anything we've previously encountered in our solar system. Comet-like features versus anomalous behavior. Here's where 3I/Atlas becomes truly enigmatic. It displays some comet-like characteristics while simultaneously exhibiting behavior that frankly just defies cometary physics. Alan Fitzsimmons from Queen's University Belfast has confirmed that the object shows a faint coma and a short tail measuring approximately 3 arc-seconds, indicating active outgassing as solar radiation heats its surface. Spectroscopic observations have detected the characteristic signature of sublimating water ice, producing the dust and gas envelope typical of approaching comets. However, Tony Farnham from the University of Maryland has noted several anomalies that challenge this interpretation. Despite its proximity to the Sun and evidence of outgassing, 3I/Atlas maintains a remarkably compact, dense appearance that differs dramatically from the fuzzy, diffuse structure of typical comets. Most puzzling is the absence of an expected extended tail, which really should be prominent given the object's size and solar distance. Bin Yang from the European Southern Observatory has observed that the outgassing patterns don't follow standard cometary models, with irregular brightness variations that suggest complex subsurface processes. The combination of active sublimation with maintained structural integrity presents a paradox. How can an object simultaneously behave like a comet while retaining characteristics more consistent with a solid engineered structure? This contradiction has sparked intense debate about whether we're observing natural cometary processes or something fundamentally different masquerading as a comet. Scientific debate: natural versus artificial. The scientific community has erupted into heated debate over the true nature of 3I/Atlas, with interpretations ranging from exotic natural phenomena to, well, potentially artificial origins. Avi Loeb, the Frank B. Baird Jr., professor of science at Harvard University, has emerged as the most vocal proponent of considering artificial origins, pointing to the statistically improbable trajectory and suspicious timing as evidence that, in his view, warrants serious investigation. Loeb argues that the mathematical precision of the object's path, combined with its optimal positioning for planetary reconnaissance, exceeds reasonable expectations for random cosmic events. His Galileo project at Harvard has been mobilized to conduct systematic observations using multiple telescopes worldwide. However, mainstream astronomers have pushed back strongly against these suggestions. Sarah Seeger from MIT acknowledges the unusual characteristics while emphasizing the importance of exhausting natural explanations before considering extraordinary possibilities. Robert Yedecke from the University of Hawaii has criticized speculation about artificial origins as premature and potentially damaging to scientific credibility. The debate highlights fundamental questions about how we interpret anomalous data and the threshold of evidence required for paradigm-shifting discoveries. Alan Stern, principal investigator of the New Horizons mission, has noted that while the characteristics are unusual, the universe is full of phenomena that initially appear impossible until we develop a better understanding of the underlying physics. Spectral analysis mysteries. The spectroscopic data from 3I/Atlas is revealing some puzzling inconsistencies that are, honestly, challenging our understanding of interstellar object composition. Stephanie Milam from NASA Goddard Space Flight Center has been coordinating observations using the James Webb Space Telescope to conduct detailed infrared spectroscopy of the object's composition. Initial results confirm the presence of water-ice spectrum, but the patterns just don't match our expected models. Jacqueline Keene from Boston University has identified these anomalous spectral signatures, where the observed signals actually increase in regions where water-ice models predict they should decrease. This contradiction suggests either unknown compositional elements or maybe structural properties that don't conform to standard cometary models. Now the object exhibits a distinctly reddish coloration, similar to objects in our outer asteroid belt, yet its interstellar origin kind of rules out formation in our solar system. Michelle Bannister from the University of Canterbury has noted that attempts to determine precise composition are complicated by the active coma surrounding the nucleus, which creates interference in spectral measurements. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory has suggested that these unusual spectral characteristics might indicate exotic ice compositions or internal structures not found in solar system objects. So, these spectroscopic mysteries really add another layer of intrigue to an already enigmatic visitor, suggesting that 3I/Atlas may be composed of materials or structured in ways we just don't yet understand. Dark forest hypothesis implications. The behavior patterns of 3I/Atlas align remarkably well with theoretical models of how an advanced civilization might conduct reconnaissance while avoiding detection. The dark forest hypothesis, popularized by Chinese science fiction author Liu Cixin, suggests that intelligent civilizations remain hidden to avoid potential threats from other species. Seth Shostak from the SETI Institute has noted that 3I/Atlas exhibits what could be interpreted as stealth-like behavior, deliberately timing its closest solar approach when Earth would be positioned to block optimal observation. This timing ensures that the most detailed study phase occurs when our planet's scientific instruments have limited access to the visitor. Jill Tarter, former director of SETI research, has observed that the trajectory allows for comprehensive surveying of inner solar system planets, while minimizing exposure to potential detection by any resident intelligence. The orbital path provides optimal vantage points for studying Earth's atmosphere, Mars's surface conditions, and Venus's cloud dynamics, exactly the type of data an exploring civilization would prioritize. Frank Drake, creator of the famous Drake equation, noted before his passing that such reconnaissance patterns would represent logical exploration strategies for risk-averse civilizations. While most scientists remain skeptical of artificial explanations, the behavioral patterns of 3I Atlas do match theoretical models of how cautious interstellar explorers might operate when encountering potentially inhabited star systems. Historical context and lessons. The discovery of 3I Atlas comes with profound lessons learned from our missed opportunities with previous interstellar visitors. When 1I Oumuamua was discovered in 2017, the scientific community was caught completely unprepared for studying such a rare phenomenon. Robert Warwick, who discovered Oumuamua using the Pan-STARRS 1 telescope, has reflected on how the object's rapid departure left many critical questions unanswered. The mysterious acceleration exhibited by Oumuamua without visible outgassing remains unexplained to this day, highlighting the importance of comprehensive observation campaigns. Gennady Borisov, the amateur astronomer who discovered 2I Borisov in 2019 from his observatory in Crimea, provided the astronomical community with a second chance that was better utilized. However, even Borisov's study was limited by available technology and coordination protocols. Mark Norris, from the University of Central Lancashire, has emphasized that 3I Atlas represents our most comprehensive opportunity yet to properly study an interstellar visitor with advanced instruments and coordinated global observation campaigns. The improved detection capabilities of modern sky surveys, combined with rapid communication networks, have enabled real-time coordination among observatories worldwide. Michelle Bannister has noted that the lessons learned from previous interstellar encounters have fundamentally changed how the astronomical community approaches these rare events, ensuring that we're better prepared to unlock the secrets these cosmic messengers carry from distant star systems. Future observations and implications. The coming months represent a critical window for determining the true nature of 3I Atlas before it departs our solar system forever. Perihelion is scheduled for October 30, 2025, after which the object will begin its journey back toward interstellar space. Paul Chodas has calculated that 3I Atlas will re-emerge from behind the Sun in December 2025, providing a final opportunity for detailed observations before it becomes too distant for meaningful study. Karen Meach is coordinating an unprecedented international observation campaign involving over 50 professional observatories and numerous space-based instruments. The Hubble Space Telescope, James Webb Space Telescope, and ground-based facilities including the Very Large Telescope in Chile are all dedicating precious observation time to this cosmic visitor. Daryl Seligman has noted that the data collected during this campaign will either confirm 3I Atlas as an exotic but natural interstellar comet, or potentially revolutionize our understanding of what's possible in our cosmic neighborhood. The implications extend far beyond pure astronomy. If 3I Atlas proves to be artificial, it would fundamentally alter humanity's perspective on our place in the universe and our approaches to planetary defense and interstellar communication. Alan Fitzsimmons emphasizes that regardless of the final interpretation, 3I Atlas represents a pivotal moment in astronomy, where advanced technology meets unprecedented opportunity to study materials and possibly intelligence from beyond our solar system. As 3I Atlas continues its mysterious journey through our solar system, it challenges everything we thought we knew about interstellar visitors. Whether this ancient wanderer is an exotic natural phenomenon or something far more extraordinary, it's forcing us to expand our understanding of what's possible in the cosmos. The next few months will be crucial in determining the truth about this enigmatic visitor before it disappears back into the depths of space. Stay tuned to InnoVision Tech for the latest updates on this cosmic mystery. Like, share, and subscribe. So, Bill Nye just received data from Voyager 1 that's making him lose sleep at night. Did you know that interstellar space was supposed to be empty and peaceful? For 45 years we believed the void between stars was just that, a void. But Voyager 1 has shattered this assumption by discovering violent plasma storms raging through what we thought was cosmic nothingness. These invisible tsunamis of superheated gas are powerful enough to destroy spacecraft and rewrite everything we know about deep space, the terrifying truth we've been planning humanity's cosmic future based on a lie. The epic journey of Voyager 1. What if I told you that right now, as you're watching this video, there's a tiny spacecraft the size of a small car racing through the darkest corners of space at 38,000 miles per hour, carrying humanity's most ambitious message to the stars. This is the incredible story of Voyager 1, a machine that has redefined what's possible in human exploration. Launched in 1977 when disco was king and the internet was just a dream, this remarkable probe has been on the ultimate road trip for over 45 years, traveling more than 14 billion miles from Earth. To put that distance in perspective, light from the sun takes over 22 hours to reach Voyager 1, meaning if something happened to it right now, we wouldn't know for almost a full day. Originally designed for a simple 4-year mission to snap some photos of Jupiter and Saturn, Voyager 1 had other plans. Like that friend who says they're just stopping by for a quick visit and ends up staying for decades, this little spacecraft just kept going, and going, and going. It's now the farthest human-made object from our planet, sailing through a region of space that no human technology has ever explored before, interstellar space itself. Every second, it's pushing deeper into the cosmic unknown, sending back data that's completely changing how we understand the universe around us. The terrifying discovery that shocked scientists. Scientists are calling it the most disturbing space discovery in human history, and it's happening right now, 14 billion miles away from Earth. When Bill Nye uses the word terrifying to describe a scientific discovery, you know we're dealing with something that has fundamentally shaken the space science community to its core. As Voyager 1 crossed into the mysterious realm of interstellar space, that vast, supposedly empty region between star systems, it began detecting something that no scientist had ever predicted or prepared for. We're talking about massive plasma waves rippling through the cosmic void like invisible tsunamis of superheated, electrically charged gas. These aren't gentle whispers from space. They're powerful, chaotic energy signatures that seem to be erupting from unknown sources in the darkness beyond our solar system. Even more unsettling are the bizarre magnetic field fluctuations that Voyager 1 is recording. Twisted, violent distortions that create a kind of cosmic storm system that never ends. The implications are staggering because for decades, scientists believed interstellar space was essentially a calm, predictable void with maybe some scattered particles floating around. Instead, Voyager 1 has revealed that the space between stars is more like a raging ocean of energy that could pose serious threats to any future spacecraft, or humans, brave enough to venture into the interstellar medium. This discovery isn't just rewriting textbooks, it's forcing us to completely reconsider what lies beyond our cosmic neighborhood. What Voyager 1 actually found out there. For 45 years we've been completely wrong about what exists in the space between stars, and the truth is far more dangerous than anyone dared to imagine. The cosmic revelation that Voyager 1 has delivered is nothing short of mind-blowing, completely shattering decades of scientific assumptions about interstellar space. While textbooks taught us that the region between star systems was essentially a cold, empty vacuum with maybe some scattered hydrogen atoms drifting around, Voyager 1 has exposed this as a dangerous misconception. Instead of finding peaceful emptiness, our brave little explorer has discovered that interstellar space is absolutely buzzing with violent activity. We're talking about massive plasma waves that surge through the darkness like invisible tsunamis of superheated, electrically charged particles. These plasma waves aren't just gentle ripples, they're powerful enough to interfere with spacecraft electronics and potentially destroy sensitive equipment. Even more disturbing, the magnetic fields in this region are completely chaotic and unpredictable, twisting and writhing in ways that create a kind of electromagnetic storm system that never stops raging. The data streaming back from Voyager 1 reveals that what we thought was a calm cosmic highway is actually more like navigating through a perpetual hurricane of energy and charged particles. This discovery has forced scientists to completely reimagine interstellar space as a hostile, dynamic environment filled with invisible dangers that could pose serious threats to any future deep space missions or interstellar travelers foolish enough to venture into this cosmic tempest. Why this discovery changes everything we know. Every space mission, every interstellar travel plan, every assumption about humanity's cosmic future just became obsolete, and it's all because of what one tiny probe discovered in the darkness. This isn't just another fascinating space fact that you'll forget by tomorrow. Voyager 1's discovery is literally forcing scientists to tear up decades of research and start over from scratch. For years, space agencies around the world have been designing future missions based on the fundamental assumption that interstellar space was a relatively calm, predictable environment, where spacecraft could cruise safely between star systems. Engineers calculated fuel requirements, mission timelines, and safety protocols, all based on the idea that once you left our solar system, you'd encounter mostly empty space with maybe some gentle cosmic winds. Now we're learning that assumption was catastrophically wrong. The space between stars is more like a cosmic hurricane that never ends, filled with violent plasma storms and chaotic magnetic fields that could tear apart any unprepared spacecraft. This means every calculation about future deep space missions needs to be completely recalculated, every plan for interstellar travel must be reconsidered, and every assumption about what lies beyond our solar neighborhood has to be thrown out the window. We're essentially discovering that we've been planning to sail across what we thought was a peaceful lake, only to find out it's actually a raging ocean filled with invisible storms that could destroy anything foolish enough to venture into them without proper preparation. Bill Nye's eye-opening explanation. When the science guy himself calls a discovery terrifying, you know we're dealing with something that could fundamentally change humanity's place in the universe. Bill Nye's reaction to Voyager 1's discovery reveals just how profoundly this finding has shaken the scientific community, and when you hear his explanation, you'll understand why even seasoned space experts are genuinely concerned. According to Nye, these plasma waves and magnetic anomalies aren't just fascinating cosmic phenomena to study from a safe distance. They represent genuine, unknown dangers that could catastrophically impact any future spacecraft attempting to venture into deep space. The science guy emphasizes that this isn't the realm of science fiction movies or theoretical physics. This is real, hard data streaming back from actual instruments, showing us that interstellar space is far more hostile and unpredictable than our most pessimistic models ever suggested. What makes Nye's assessment particularly alarming is his point about scale. If a relatively small, robust probe like Voyager 1 is detecting these massive energy signatures and chaotic magnetic disturbances, the implications for larger spacecraft carrying human crews are genuinely frightening. He explains that these discoveries force us to confront an uncomfortable truth. We've been making plans for interstellar exploration based on assumptions that were completely wrong, and now we're learning that the space between stars might be one of the most dangerous environments in the entire universe. Nye's concern isn't just scientific curiosity, it's a wake-up call about the real challenges facing humanity's cosmic ambitions. The mind-blowing science behind the discovery. The universe just revealed one of its most terrifying secrets, and the science behind it is so mind-bending that it's forcing us to rewrite everything we thought we knew about the cosmos. What Voyager 1 has uncovered in the depths of interstellar space is a cosmic phenomenon so extraordinary that it reads like something from a science fiction nightmare, except this is absolutely real and happening right now. We're dealing with plasma, often called the fourth state of matter, which forms when ordinary gas becomes so incredibly hot that electrons get violently ripped away from their atoms, creating a supercharged soup of particles that can carry devastating amounts of energy across vast distances. In the supposedly empty void between stars, this plasma is creating waves that travel at mind-numbing speeds, interacting with twisted magnetic fields in ways that generate a kind of cosmic symphony from hell. Except this symphony never stops playing and could potentially destroy anything that gets too close. The magnetic fields themselves are being warped and compressed by mysterious forces that scientists don't fully understand, creating a chaotic electromagnetic environment that's completely unlike the relatively stable magnetic conditions we're used to in our solar system. What makes this discovery even more unsettling is that these plasma waves can interfere with electronic systems, disrupt communications, and potentially damage spacecraft hulls through processes that we're only beginning to comprehend. We're essentially learning that interstellar space operates like a massive invisible storm system that's been raging for billions of years, completely hidden from our view until now. The incredible instruments making these discoveries. So, the most groundbreaking space discovery in human history is actually being made by technology that's, older than the internet, weaker than your smartphone, and somehow still working perfectly after 45 years out there in the cosmic deep. What makes Voyager 1's terrifying discovery even more remarkable is that it's being detected by instruments built using 1970s technology. We're talking about equipment that has less computing power than a basic calculator, yet it's revolutionizing our understanding of the universe in ways that, honestly, modern supercomputers couldn't have predicted. The key instrument responsible for these mind-blowing discoveries is called the plasma wave subsystem, which basically acts like a cosmic radio that can hear the electrical symphony of death playing out in the void between stars. This incredible device has been faithfully transmitting data back to Earth for over 4 decades, surviving conditions that would instantly destroy any human. We're talking about temperatures of -270 degrees Fahrenheit, constant bombardment by cosmic radiation that would be lethal in seconds, and the complete isolation of deep space where the nearest help is literally billions of miles away. The fact that this ancient technology is still functioning flawlessly while making discoveries that are forcing scientists to completely rewrite textbooks is, well, nothing short of miraculous. Every single day, this 45-year-old instrument keeps probing the hostile environment of interstellar space, sending back data that reveals just how dangerous and unpredictable the cosmic void really is, proving that sometimes the most extraordinary discoveries come from the most unexpected sources. The extreme challenges of deep space exploration. Right now, 14 billion miles from Earth, a spacecraft smaller than your car is facing challenges so extreme that they make climbing Mount Everest look like a casual stroll through the park. Voyager 1's groundbreaking discovery becomes even more incredible when you realize the absolutely brutal conditions this tiny explorer has endured to bring us this terrifying revelation about interstellar space. We're talking about a spacecraft that's so impossibly far from home that when Mission Control sends a command, it takes over 22 hours for the signal to reach Voyager 1, meaning if something catastrophic happened right now, we wouldn't even know about it until tomorrow. This brave little probe is operating in a hellish environment where temperatures plummet to -270 degrees Fahrenheit, just 3 degrees above absolute zero, while being constantly pummeled by cosmic radiation so intense it would kill a human being in mere minutes. The spacecraft is running on a slowly dying nuclear power source that's been faithfully providing energy for nearly half a century, yet somehow it's still transmitting crystal-clear data about the plasma storms and magnetic chaos surrounding it in the cosmic void. What makes this achievement even more mind-blowing is that Voyager 1 is essentially flying blind through an environment that no human has ever mapped or understood, navigating through invisible energy storms that could potentially destroy its delicate instruments at any moment. The fact that this ancient piece of human engineering is not only surviving but thriving in the most hostile environment imaginable, while making discoveries that are revolutionizing space science is nothing short of miraculous. What this means for the future of humanity. The discovery that's keeping space scientists awake at night isn't just about understanding the universe, it's about whether humanity has any future beyond Earth at all. Voyager 1's terrifying revelation about the hostile nature of interstellar space has profound implications that extend far beyond scientific curiosity. We're talking about the very survival of our species, and our dreams of becoming a multiplanetary civilization. If humanity ever hopes to send crews to other star systems, we now know they'll be facing an invisible gauntlet of plasma storms and chaotic magnetic fields that could interfere with life support systems, fry critical electronics, or even breach spacecraft hulls through processes we're only beginning to understand. The discovery forces us to confront an uncomfortable reality. Our species has been making grand plans for interstellar colonization based on the assumption that space between stars was mostly empty and safe, but we're now learning it's more like a cosmic minefield that's been waiting to destroy anything foolish enough to venture into it unprepared. On a deeper philosophical level, this discovery serves as a humbling reminder of how little we actually know about our cosmic neighborhood, and how dangerous our universe really is. We've been living in our solar system like sheltered children who've never left their safe hometown, only to discover that the wider world is filled with hurricanes, earthquakes, and tsunamis we never knew existed. The question now isn't just whether we can reach other stars, but whether we can survive the journey through the hostile wilderness that separates us from them. The future of space exploration after this discovery. The most terrifying space discovery in history has just triggered the biggest revolution in spacecraft design since humans first dreamed of reaching the stars. Voyager 1's shocking revelation about the violent nature of interstellar space has already set off a chain reaction that's completely transforming how we approach deep space exploration, with engineers and scientists scrambling to redesign everything from spacecraft hulls to mission timelines. space agencies around the world are now frantically developing new technologies that can withstand the brutal plasma storms and chaotic magnetic fields that Voyager 1 has revealed lurking in the cosmic void. We're talking about revolutionary shielding systems, advanced electronics that can survive electromagnetic chaos, and completely new propulsion methods that could get spacecraft through the dangerous interstellar medium faster than ever before. NASA and other organizations are already planning specialized follow-up missions designed specifically to study these mysterious plasma waves and magnetic anomalies in greater detail, hoping to understand exactly what future explorers will face when they venture beyond our solar system's protective bubble. The discovery has also sparked renewed interest in developing faster-than-light travel concepts and exotic propulsion systems that could potentially bypass the worst of these interstellar dangers entirely. What's most exciting is that this terrifying discovery has essentially created an entirely new field of space science, interstellar plasma dynamics, and we're just scratching the surface of understanding what's really out there in the cosmic deep. The future of space exploration will never be the same, and that's both thrilling and absolutely terrifying. And there you have it, Voyager 1's terrifying discovery that's completely changing how we understand the universe beyond our solar system. The space between stars isn't the peaceful void we thought it was, but a raging storm of plasma waves and chaotic magnetic fields that could reshape the future of human space exploration forever. If this mind-blowing revelation about our cosmic neighborhood fascinated you as much as it did me, make sure to hit that subscribe button and ring the bell icon so you never miss another incredible discovery from InnoVision Tech. Drop a comment below and let me know, which part of Voyager 1's journey shocked you the most? Until next time, keep exploring the impossible. Russia commands one of the largest and most technologically advanced air forces in the world, boasting over 4,000 aircraft in active service. Its strategic bombers alone can reach targets thousands of kilometers away, projecting power on a global scale. But here's a striking fact. Russia's Tu-160 White Swan remains the fastest bomber ever built, capable of speeds over Mach 2. Do you know what makes this aircraft a game-changer in modern air warfare? Modernization of the Russian Air Force. Modernization of the Russian Air Force. Russian air power in 2025 is undergoing a transformation that's reshaping the balance of aerial strength on the global stage. At the heart of this evolution is the ambitious modernization of the Russian Air Force, driven by the introduction of cutting-edge aircraft designed to rival the best in the world. The Su-57, Russia's fifth-generation stealth fighter, stands out as a symbol of this leap forward. Combining stealth technology, supersonic speed, and advanced avionics, the Su-57 is engineered not just to survive in contested airspace, but to dominate it. This fighter is equipped with sophisticated sensors and weaponry that enable it to engage multiple targets simultaneously, making it a formidable opponent in any aerial engagement. Beyond the Su-57, Russia is upgrading its fleet of Su-35 and Su-30 fighters, ensuring that even its fourth-generation aircraft remain highly capable and relevant. This modernization effort isn't just about hardware. It also reflects a strategic shift toward greater operational flexibility and networked warfare. The Russian Air Force is integrating its aircraft with advanced command and control systems, allowing pilots to share real-time information and coordinate complex missions with precision. This interconnected approach enhances situational awareness and multiplies combat effectiveness. While challenges like budget constraints and aging infrastructure persist, Russia's commitment to revitalizing its air power signals its determination to maintain a credible and modern aerial force. The modernization of the Russian Air Force is not just about keeping pace with rivals, it's about asserting Russia's role as a dominant air power well into the future. Strategic bomber capabilities. Strategic bomber capabilities. How does a nation project power across continents without launching a single missile? The answer often lies with its strategic bomber fleet, and in 2025, Russia's capabilities in this domain remain a critical aspect of its air power. The formidable Tu-160, often dubbed the White Swan, continues to be the crown jewel of Russia's long-range aviation. This supersonic variable sweep wing bomber isn't just fast. It's designed to penetrate sophisticated air defenses and deliver both conventional and nuclear payloads over vast distances. Its recent upgrades include new engines and modern avionics, significantly extending its operational life and enhancing its combat effectiveness. Complementing the Tu-160 is the enduring Tu-95 Bear, a turboprop-powered strategic bomber that, despite its age, remains a reliable workhorse. The Tu-95 has also undergone modernization, incorporating new cruise missiles that allow it to strike targets from standoff ranges, minimizing exposure to enemy air defenses. These bombers are not merely delivery platforms, they are symbols of Russia's global reach and deterrence capabilities. Their presence in long-duration patrols over international waters serves as a clear demonstration of force, projecting influence far beyond Russia's borders. The strategic bomber fleet also plays a crucial role in supporting naval operations and conventional strike missions, offering a versatile platform for various military objectives. The continuous development and deployment of these bombers underscore Russia's commitment to maintaining a robust long-range aviation component, ensuring its ability to respond to threats and project power on a global scale for years to come. Drone and UAV integration. Drone and UAV integration, unmanned aerial vehicles have become a game-changer in modern warfare, and Russia is no exception in harnessing their potential to boost air power in 2025. The Russian military has accelerated the integration of drones and UAVs into its air force, recognizing their value not only for reconnaissance, but also for electronic warfare and precision strikes. These drones provide commanders with real-time intelligence, allowing for faster decision-making and more effective targeting without putting pilots at risk. Russia's UAV programs include a variety of platforms, from smaller tactical drones used for battlefield surveillance to larger armed drones capable of carrying out strike missions. What sets Russian drone development apart is the emphasis on electronic warfare capabilities embedded within these systems, enabling them to jam enemy communications and radar, disrupting adversary operations before a single missile is launched. This blend of reconnaissance, strike, and electronic attack roles makes drones a versatile force multiplier in Russia's aerial arsenal. Additionally, the use of drones in recent conflicts has provided valuable combat experience, helping refine tactics and improve drone technology. The growing drone fleet also complements manned aircraft by performing high-risk or prolonged missions, preserving pilot safety while maintaining battlefield pressure. As Russia continues to invest in drone innovation, including AI-assisted targeting and swarm technologies, its air power is evolving into a more flexible, networked force capable of dominating contested airspace. This shift not only enhances Russia's tactical options, but also signals a broader trend in warfare, where unmanned systems increasingly define air superiority. Air defense system synergy. When it comes to defending vast airspace, Russia doesn't rely on fighter jets alone. Its air defense systems form an impenetrable shield that complements its Air Force operations. The S-400 Triumph system is arguably the crown jewel of this layered defense network, capable of tracking and engaging multiple aerial targets, including stealth aircraft and ballistic missiles, at ranges exceeding 400 kilometers. But Russia isn't stopping there. The introduction of the S-500 Prometei promises to revolutionize air defense with even greater range, faster tracking, and the ability to intercept hypersonic threats. These systems don't operate in isolation. They are tightly integrated with Russian aircraft and command centers, creating a seamless web of detection and interception. This synergy allows pilots to maneuver with confidence, knowing that ground-based defenses cover their flanks. The combination of advanced radar, missile technology, and electronic warfare creates a multi-layered fortress that complicates any adversary's attack plans. Moreover, the mobility of these systems means they can be rapidly deployed to hotspots, adapting to shifting threats in real time. This integration of air defense and Air Force assets exemplifies Russia's approach to modern warfare, combining offense and defense into a cohesive, highly responsive force. As air threats evolve with new stealth and hypersonic technologies, Russia's layered air defense network ensures it remains a formidable challenge for any potential aggressor aiming to penetrate its skies. This strategic blend of technology and coordination is a key pillar of Russian air power in 2025, making its airspace one of the most heavily defended in the world. Electronic warfare and cyber capabilities. In modern aerial warfare, dominating the electromagnetic spectrum can be just as decisive as controlling the skies. Russia's investment in electronic warfare and cyber capabilities has become a cornerstone of its air power strategy in 2025. These advanced systems are designed to disrupt enemy radar, communications, and navigation, effectively blinding and confusing opposing forces before a single missile is fired. Russian EW units can jam or spoof enemy sensors, degrade targeting accuracy, and protect their own aircraft from detection, creating a significant tactical advantage. This electronic dominance extends beyond traditional jamming. It includes cyber operations that target command and control networks, undermining enemy coordination and response times. The integration of EW capabilities with manned and unmanned platforms allows Russia to conduct complex operations where electronic attacks soften defenses and pave the way for precision strikes. Recent conflicts have demonstrated how Russian electronic warfare can neutralize technologically superior adversaries by exploiting vulnerabilities in their systems. This layered approach to electronic and cyber warfare not only enhances survivability but also forces opponents to adapt costly countermeasures, slowing their operational tempo. As air combat increasingly relies on sensors and data, Russia's focus on EW ensures it remains a formidable force capable of shaping the battlefield environment itself. This blend of electronic disruption and cyber offense is transforming Russian air power into a multi-dimensional threat, where control over information and technology is as critical as firepower. Training and readiness. What separates a good pilot from a great one? In 2025, Russia's air power relies heavily on the skill and readiness of its aviators, who undergo rigorous training designed to prepare them for the complexities of modern aerial combat. Russian pilots don't just fly, they train in highly realistic simulations that replicate the intense pressures of real battle, including electronic warfare environments and multi-threat scenarios. This continuous, immersive training sharpens their reflexes and decision-making, enabling them to operate advanced aircraft like the Su-57 and Su-35 with precision and confidence. Beyond individual skills, Russia emphasizes teamwork and coordination, conducting large-scale exercises that integrate air, ground, and naval forces to simulate joint operations. These drills test pilots' ability to adapt quickly, communicate effectively, and execute complex missions under stress. The Russian Air Force also invests in updating its training infrastructure, incorporating virtual reality and AI-driven tools to enhance learning outcomes. This focus on readiness ensures that when conflict arises, Russian pilots can maximize the capabilities of their aircraft and systems. Despite technological advances, human expertise remains a decisive factor in air superiority, and Russia's commitment to pilot training reflects an understanding that cutting-edge hardware is only as effective as the people who operate it. In a rapidly evolving battlefield, this blend of advanced technology and elite training keeps Russia's Air Force agile, lethal, and ready to face a wide range of challenges. Export and international influence. So, how does a country extend its influence beyond its borders without firing a single shot? Well, Russia's air power strategy in 2025 really leverages military exports as a powerful tool to build alliances and project influence worldwide. By supplying advanced aircraft like the Su-35 and MiG-29 to allied nations, Russia not only strengthens these countries' defense capabilities, but also deepens strategic partnerships. These exports come with training, maintenance, and technology transfers that create long-term dependencies, ensuring Russia's presence in key regions. This approach goes way beyond just selling hardware. It's really about shaping geopolitical dynamics through military cooperation. Countries in Asia, the Middle East, and Africa have become major recipients of Russian aircraft, benefiting from proven technology at competitive prices. This export strategy also fuels Russia's defense industry, providing funds that support further research and development. Moreover, by showcasing its aircraft in international air shows and joint exercises, Russia demonstrates the reliability and effectiveness of its air power, attracting new customers and, reinforcing its global standing. This blend of commerce and diplomacy through military aviation helps Russia maintain a foothold in regions critical to its interests, even where direct military presence is limited. In 2025, Russian air power isn't just about what happens in the skies over its own territory. It's also about extending reach and influence through the wings of its allies, making military exports a key pillar of its broader strategic vision. Challenges and limitations. Even the most advanced Air Force faces hurdles, and Russia's air power in 2025 is no exception. Despite some pretty impressive modernization efforts, there are several challenges that threaten to slow progress and limit operational effectiveness. One of the biggest obstacles is budget constraints, which really impact the pace of aircraft production, upgrades, and maintenance. Modern fighter jets like the Su-57 are just super expensive to build and maintain, and limited funding means Russia has to carefully balance new acquisitions with sustaining its existing fleet. Another issue lies in aging infrastructure. Honestly, many air bases and support facilities require modernization to keep up with the demands of advanced aircraft and digital warfare systems. Without upgrades, these facilities can become bottlenecks, which reduces readiness and response times. Additionally, Russia faces difficulties in sourcing some high-tech components domestically due to sanctions and export restrictions, which forces reliance on alternative suppliers or indigenous development, and that can delay projects. Maintaining operational readiness while transitioning to newer platforms is also a really delicate balancing act. Retiring older aircraft too quickly risks gaps in capability, while keeping them too long strains resources and logistics. Furthermore, pilot shortages and the need for continuous advanced training add even more complexity to sustaining an effective force. These challenges don't negate Russia's air power, but they do highlight the realities of modern military development. Overcoming these hurdles is going to require strategic planning, investment, and innovation. Russia's ability to address these limitations will ultimately shape how effectively its air force can project power and defend its interests in the years ahead. Role in hybrid and regional conflicts. When air power meets real-world conflict, theory turns into hard-earned experience. Russian air forces have actively participated in hybrid and regional conflicts over the past decade, using these engagements as live testing grounds for tactics, technology, and operational concepts. Syria, for instance, became a proving ground where Russia deployed a mix of advanced fighters, bombers, drones, and electronic warfare systems to support ground operations and test new weapons under combat conditions. These missions provided invaluable data on the effectiveness of precision strikes, air defense suppression, and coordination with other military branches. Similarly, ongoing involvement in Ukraine has pushed Russian air power to adapt rapidly to evolving threats, including countering Western-supplied air defense systems and drones. These conflicts have exposed both strengths and vulnerabilities, which has driven accelerated modernization and tactical innovation. The experience gained has influenced pilot training, drone deployment strategies, and electronic warfare tactics, making the Russian Air Force more battle-hardened and versatile. Moreover, these regional engagements highlight Russia's ability to project air power in complex environments where conventional warfare blends with asymmetric threats. This practical application of air power ensures that Russia's aerial capabilities are not just theoretical, but tested and refined in the crucible of conflict. As a result, Russian air power in 2025 is shaped by real combat experience, making it a dynamic force that continues to evolve in response to modern warfare's challenges and demands. Future outlook and developments. So, what will the future of Russian air power look like beyond 2025? The answer, honestly, lies in a bold vision that combines cutting-edge technology with strategic innovation to maintain and expand air superiority. Hypersonic weapons are at the forefront of this evolution, promising to revolutionize strike capabilities by delivering ultra-fast, hard-to-intercept attacks that can overwhelm enemy defenses. Russia is actively integrating these weapons into its bomber and missile platforms, aiming to create a new level of deterrence and battlefield dominance. Alongside hypersonics, the expansion of drone fleets, especially autonomous and swarm technologies, will totally redefine how Russia conducts reconnaissance and offensive operations, allowing for more flexible, persistent, and cost-effective missions. Stealth technology is also evolving, with continuous improvements to aircraft like the Su-57, and potential new designs that enhance survivability in increasingly contested airspaces. Beyond hardware, Russia is investing heavily in artificial intelligence and network-centric warfare, enabling faster data sharing, improved targeting, and more coordinated multi-domain operations. This future-focused approach really reflects an understanding that tomorrow's air battles will be fought not just with speed and firepower but with information dominance and technological edge. While challenges remain, Russia's commitment to innovation ensures its air force will remain a formidable force capable of adapting to emerging threats and maintaining strategic influence. The trajectory of Russian air power is clear, a blend of advanced weapons, smart technology, and integrated systems designed to secure its place as a dominant aerial power well into the next decade and beyond. Thanks for watching this deep dive into Russian air power with InnoVision Tech. If you enjoyed the video and want to stay updated on the latest in technology and innovation, make sure to hit that subscribe button and ring the bell icon so you never miss an update. We'd love to hear your thoughts. Drop a comment below and tell us what fascinates you most about modern air forces or what topics you want us to cover next. Stay curious, and let's explore the future of tech together.